Hey guys, welcome to the channel Unshackling Sudokus and Puzzles. Today's video will be on a killer palindrome Sudoku created by Jonny Kaufman. I came across this Sudoku yesterday and I was surprised to notice that despite being posted 25 days back, this Sudoku has very few solves. Maybe the people found this Sudoku hard, or maybe this Sudoku went unnoticed in the portal. I'm not really sure, but I solved this yesterday and I thought that this Sudoku certainly deserves a lot more solves. It was very interesting for me to solve, and we are glad to make a video on this Sudoku for you guys. And as you can see, there is a beautiful fish-shaped line in the center of the grid. So it rather looks like an aeroplane taking off, right? So let us move on to the rules. Classic rules apply. Each row, each column and each 3 by 3 box will have digits from 1 to 9 without repetition, and killer rules apply. All the cells encompassed by dotted lines will have non-repeating digits, and the sum of those digits will be the clue given in the top left corner. And the last part is the palindrome rule. Along this red line, this fish-shaped line, the digits will be the same across the two extremities. Like it will be a palindrome. So if you have a 2, for example, here, so you'll have a 2 here, and starting from this end until the middle, and starting from this end until the middle, the sequence of digits would be the same. Even you have an example in the rules. Digits along the fish-shaped red line form a palindrome, and 1, 2, 3, 4, 5, 4, 3, 2, 1, that sequence forms a palindrome. So these are the rules. If you want to start this Sudoku yourself, the link to solve is in the description of the video. Do give it a try before watching the video. You'll be able to appreciate the Sudoku more. So having said that, we'll start solving the Sudoku now. Okay. So the first thing to notice in the Sudoku is this cage. So you can see that this is a 7-cell cage and the total is quite high, 42. So in a Sudoku, in any row, column or a 3 by 3 box, the sum of digits from 1 to 9 will always be 45. So when you have a 7-cell cage with total 42, you need to exclude 2 digits such that their sum is 3, and the only way to do that is by removing 1 and 2 from this cage. So which means that in column 1, we can corner pencil mark 1, 2 in these 3 cells, right? There is no other possibility for the 1, 2 in any cell in that column. Now I can't have both 1 and 2 in these 2 cells, because then I won't be able to satisfy the 13. So which means that this digit has to be 1 or 2 no matter what, and the next out of those 1 and 2 has to go into the 13 cage. Now we know that this is a palindrome, so the third cell starting from this end will also be the same, so it has to be 1 and 2. So let us mark the middle digit in this line. Maybe it would be helpful in the later of the solve. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have counted 11 digits on either end of the line, and this would be the middle cell. So let me mark that cell. So we can use this as reference to compare cells across the line. Okay, so the next thing to see in this Sudoku is, if you look at this big 39 cage, it has 1, 2, 3, 4, 5, 6 and 7. Again 7 cells just like this 42 cage. So we need to exclude 2 digits such that their sum is 6, because the total is 39. So we need to exclude 2 digits such that their sum is 6, and the only possibilities are 1 and 5 or 2 and 4. Now if you observe this cell, row 3 column 6, right? So let me highlight that cell. And the palindrome cell for this is 1, 2, 3, 4, 5 and 6, right? 1, 2, 3, 4, 5, 6. So this cell. So you will notice that whatever goes into these cells cannot be present in the 39 cage, right? So, and we know that the only possibilities for getting the excluding digits from 39, excluding digits from 45 in such a way that the total is 39 is 1 and 5 or 2 and 4. So which means that the red cells would be 1, 2, 4 and 5. The only possibilities for that, because it's not going to be present in the 39 cage. And now quickly we can remove 1 and 2 from here because of this, and this also becomes 4 and 5. So that is interesting. So we are not sure if the possibilities which are getting excluded are 2 and 4 or 1 and 5. So we can go into that. And there is something interesting in this box. In box 4, you'll notice that there are 6 cells which sum up to 30. So these 3 cells will sum to 15, so that the box total gets to 45. And to satisfy the 42 kg, these 4 cells must sum to 27, right? They will add up to 27. And when you have 4 cells which sum to 27, 9 will surely be part of the sum. Without a 9, you cannot reach 27 with 4 digits. So 9 is going to be surely a part of the 27 sum. So we also have something interesting going on with the 38 kg, but it is too early to go to that side. We just know that this is also a 7 cell cage, and we need to exclude a total of 7 with 2 digits. So it's too early to go that side. So we have some activity going on here, right, in this side. So the next thing I'm going to do is, so we know that these cells are equal. I'll remove the highlighting. So I'm going to highlight all these cells. You'll understand why I'm doing that shortly. So all these cells I've highlighted in yellow, and out of these cells I'm going to remove the cells from box 2. Basically I'm highlighting all these cells, and out of which I'm subtracting the cells in box 2, the yellow cells. So in which case all these cells, right, except row 3 column 6, rest of the cells will get cancelled out because they are common between both the sides. In the first instance we took these 2 cells and the full box, and in the second instance I am taking this full box, which means that the common cells will get eliminated, so they become white. I'll change this to a different color. This is on the left side of the expression, and from that I am subtracting this middle box. So this is of a different color. Okay, it is already of a different color. So we will get the sum of these 2 cells minus the sum of this cell, right? But we know that the sum of this entire 3, what is this? You have 2 cages, right? 39 plus 14 is 53, and out of which you are subtracting this box. So 53 minus 45. So I will get the sum of the red cells minus the yellow cell, right? So 53 minus 45. So the sum of these 2 cells minus this cell will be equal to 8, right? So this is useful because let's say suppose you have a 4 in this cage, right? So this will also become a 4 due to the palindrome, and we know that to have a difference of 8, these 2 cells will sum up to 12 because that's 4. So these 2 cells will have to sum up to 12, and it can't be 4 plus 8 and 3 plus 9. So this would be 5 and 7. And can we make the 27 total? Remember that these 4 cells will add up to 27, and if you have the 5, 7 here, the maximum possible sum would be 9, 8, 6 and 4, and you'll see that they sum up to 27, sir. So there is no issue there. But let us see what happens if we have a 5 in that cage. And now in order to have a difference of 8, these 2 cells will sum up to 13, and 5, 8 is ruled out, 4, 9 is ruled out, so they would be 6 and 7. And can you have 27 now from these 4 cells? You will see that it's not possible. The maximum possible sum now is going to be 9 plus 8 plus 5 plus 4, and you can reach only 26 total from these 4 cells. So when you have a 5 here, you are not going to get 27 from these 4 cells. Superb, right? A really narrow start to the Sudoku. So which means that we can be certain that this cell cannot be a 5. So that has to be a 4, and which means that has to be a 4. And now in order to have a sum of 12, this has to be 5 and 7. And the only possible way now to satisfy this would be 4, 6, 8 and 9. Superb, right? Beautiful start. I really enjoyed finding this start yesterday, guys. So this is a very fun start to the Sudoku. So the 4 is not going to go here, and these 2 cells will be 1, 2, 3 for the box, and 3 has to be in one of these cells, and 4, 6, 8 and 9. So this would have to be 3, 5, 7. Remember that 1 and 2 will not go into the cage. And now you have a 3 here, you have a 3 here. Classic gives you a 3 in one of these cells. And we know that in killer cages digits do not repeat, so both the 5 and 7 is not going to be in these 5 cells. So 5 7 goes into this cage, and now we can put in the 14 total, so that becomes 2 5 7. So we have a 2 5 7 triplet in row 1, so which means this is not a 2. So we have a 5 7 pair and a 5 7 pair, so which means 5 7 must be in these 3 cells. So coming over to this cage now, we've got some activity that is taking us to the right part of the grid. So 20 plus 11 is 31, so which means these two cells must sum up to 14. And you will know that 7 cannot be part of a 14 sum, so 7 is removed from that cell. So 7 must be in one of these two cells. Can we satisfy the box such that both 5 and 7 are inside here? Let's say this is not a 5. So which means that this quickly becomes 6 and 8, because the only way to satisfy 14 sum is now 6 and 8. 5 9 is not possible. So when you have 5 7 here, so you need to get to 8 total. 1 plus 7 is ruled out, 3 plus 5 is ruled out, and because the 6 is going outside, even 2 plus 6 is also ruled out. So which means that we are certain that the 5 is also not going inside and the 5 has to be outside. Superb. So that means this has to be a 5. 5 cannot go inside this box, and that becomes a 9 now. Which means I can remove the 9 from this cell, and 9 is going in one of these cells. Okay, so if you look at this box now, box 7, can a 1 be inside this 13 cage? So we know that if 1 is inside, then the 2 becomes outside. So if 1 is inside the cage, you need to get to 12, right? With the remaining 2 digits. And 12 has 3 options: 3 plus 9, 4 plus 8, or 5 plus 7. 3 plus 9 is ruled out because 3 pencil mark is here. 4 plus 8 is ruled out. And because 5 7 is here, there is no way to fit 5 7 in these 3 cells. Even 5 plus 7 is ruled out. So you cannot have 12 forming from those 2 cells. So 1 is not going inside the cage, which means that this would have to be a 1, and 2 has to go inside the cage now. An excellent piece of logic. And now we need to get to 11 without the 2, 3 and 4. The only possibility is 2, 5 and 6, right? For the 13 cage. So that becomes 2, 5, 6. And because of the 5 here, you get a 5 here. That becomes a 2 and 6. And I can remove the 6 from column 1, box 1. 6 is not going here. 4, 8, 9. So that becomes a 6. 1, 2, 6, 3, 4, 5. So both of these cells would be 7, 8 and 9. And I can sketch in the digits in the other end of the palindrome. So that becomes 7, 8, 9. And that's the 4th cell. So that would be 4th cell from here. So that's a 7, 8 and 9. So because of the 5 7 pair here, so that's not a 7. That becomes 8 9. So that becomes 8 9. And 7 is not going into these cells. So the only cell in box 7 for the 7 is going to be this digit, and that becomes a 7 now. So that eliminates the 7 from here. So I'll quickly write the remaining digits. So this becomes 3 8 9, and that becomes 3 8 9. So which means for the 4, so this becomes 3 8 and 9. Because I'm sorry, it is between the 7 and the 4, right? So this would have to be a 3 8 and 9. So actually, if you are solving this Sudoku in competition mode, you could have right away written that this cell is not a 2, because if you have a 2 here, this becomes a 5 7 pair, and that becomes 5 7 pair, and there is no way to resolve the Sudoku. It becomes non-unique. So in competition, you could have deduced straight away that this cell is not a 2, so this would have to be a 2, but we are solving this in leisure, right? So let us see the intended path of the author. So we got something going on here. So 5 is not in the 7 cage, because 5 is in row 9 and 5 is in column 9. So 5 is removed, and we know that we need to form a sum of 7 from the excluded digits. So which means that the other digit which is removed is 2, and 2 has to go in one of these cells for the column. And you have a 2 here because of the 2 5 7 triplet. So which means this would have to be a 2, and these 2 cells will sum up to 9. Cannot be 2 7. Cannot be 4 5, cannot be 3 6. So the only possibility is 1 plus 8, and which means that this cell has to be a 4, so that becomes 8, 9. And now we can place the 3 here, so that is a 3 for the row. So these 4 digits must be 3, 4, 6 and 7, so these cells will be 3, 6 and 7, and that would be 3, 4 and 6 because 7 can't be there. So what do we do now? So 2 gets removed from here, right? So that's not a 2. And we also have 1 as the third digit from this end of the palindrome, which means that this would have to be a 1, and that resolves this 2, 3 pair. So that has to be a 3 and that has to be a 2. And which means that this now can no longer take a 3. So that would be a 4, 6 pair, and that has to be a 3, 7 pair. So I can put these digits at the other end of the palindrome. So this would be 4, 6, that would be 4, 6, because that 4 matches to this 4. So this is 4, 6, this is 4, 6. And since both of these are different, you cannot have 4, 6 in any of these cells, or even here. None of these cells can take a 4, 6, right? So these are some of the really nice deductions that I noticed yesterday. So none of these cells can take a 4, 6. So let me look at this cell now. So it can't be 1, 5, 7, cannot be 4, cannot be 3. So 1, 3, 4, 5, 7 are ruled out. So they can only be 2, 6, 8 and 9. But you'll notice that we have a 3, 8, 9 triplet in column 3. So this cannot be 8 and 9. So which means that this would be 2, 6. And now look what it does. Can you have a 6 in this cell? The deductions are just flowing, guys. So sweet, but not so easy to find. It's a hard one, definitely. No doubt about that. So, okay. So if you have 6 in both of these cells, then 6 gets removed from both of these cells, and both of these become 4. That would lead to a problem here. So that is not a 6. So that has to be a 2. That has to be a 2. And that forces 2 in one of these cells. Can you have a 2 here? Which means you need to have the 2 here, and I don't see a problem for that. So 4, 6 and 3, 7, right? So which means this cell would be a 3, 7. And since this is the middle cell, so this matches to this and this maps to this cell. Okay, so we can just remember that. So for row 3, 1, 2, 4 and 3, 5, 7, so these two cells would be 6, 8 and 9. And we know that 2 and 5 are not the digits going to be in this cage, so the rest of the digits would be inside. So whichever comes in this cell has to go inside this cage, so that has to be a 1 or 8. So if you look at the 34 cage now, we haven't even touched it yet. We have played with all the cages, all the big cages at the corners. But if you look at this cage, this is also quite big, but we haven't yet made any deduction with that. So let us try to look at this cage now. So you need to eliminate 3 digits in such a way that they sum up to 11, right? Because this is a 6 cell cage and you need to subtract 3 digits which sum up to 11. And you will notice that you cannot exclude the 9 because then there is no way to make the 11 total. So 9 must be in these 5 cells. 9 cannot go here. So 9 must be in these 5 cells. Can you exclude the 8? If you exclude the 8 to get to the 11, the only possible way is 1 plus 2 plus 8. No other possible way. And we need to put those outside this cage in box 8 because they can't be inside the cage. So you will notice that I cannot fit 3 digits 1 to 8 inside. Maximum I can be able to fit 2 out of those 3 digits inside because these pencil marks are not helping us to match that. So which means that you also cannot exclude an 8, because if you do so, then the 3 digits getting excluded become 1, 2 and 8, and there is no way to get it outside this box now in box 8. So 8 is also inside. Let me sketch that as well. So can I remove a 7? And if you remove a 7, the only way to get to 11 is 1, 3, 7. And I can fit the 1 here and 3 and 7 here. That seems likely for now. So let us try to write some possibilities here maybe. Okay, so if you look at this cell, this is a very crucial cell in the solve, guys. So row 7, column 6, right? Let me highlight that for you. I'll remove the highlighting from these cells. Okay, let those become white now. And if you look at this cell, and this cell, both of those cells are equal. They cannot be 2, 9, they cannot be 1 and 4. So which means that 1, 2, 4, 9 are eliminated. So 3, 5, 6, 7, 8. Yes. So they would be 3, 5, 6, 7 and 8. And now you will notice that both of these cells are equal, and if I have any digit here, that digit is not going to be inside this 34K. This is a really important observation, a small observation, but a really important observation to make in the Sudoku. It's somewhat like what we did here. These two cells we did right at the start of the solve. We noticed that they cannot be in the 39K. The same idea is being used here. So, but you can't have the 8 inside in this cell, because if you have 8 here, then we are removing the 8 from this cage, but we already know that 8 is inside this cage. So that's not an 8. So it's going to be 3, 5, 6 and 7. Okay. Superb. Superb, guys. This is simply superb. Look at this cell closely. What happens if you have a 3 or 7 inside this cell? Let's say you have a 3, 7 here. So this becomes 3, 7. And we know that this cell, I'll just highlight it again for you. Let me mark this in yellow. The yellow cells are equal and the pink cells are equal. So these two cells are different. So when you have a 3, 7 pair here, these two cells form a 3, 7 pair, and you will not have any possible value in this cell. So which means that this cell cannot take 3 or 7. Superb, right? All these details you can you can get only when you look very closely to the Sudoku. So, but these are all really sharp deductions and will help you in the solve very much. So this cannot be 3, 7. That has to be a 5 or a 6. Let me remove the 3, 7 from here. That becomes 5 or 6. And now we can place the digit here, because this I had intentionally not written the 6 here because I wanted to put this digit. So you'll notice that 6 is not going here, so that puts the 6 here, and that becomes a 5. 6 is removed from that, and you're getting the value right away, which at the start seemed very unlikely. So when you remove the value from here and try to solve the grid, you'll notice that you can get this value at this stage is not very apparent at all. It's very difficult to notice that, but this cell is the weak link in the Sudoku. So both of these cells become 5, and now this cage gets resolved, so that becomes a 5, and that resolves this 5, 7 pair, that resolves this 7, 2 pair, and these two cells has to be 1, 8, 9. And now I'll notice that in box 5 has only one cell left, so that becomes 5, and that resolves this 5 here, so that is a 5, so that becomes a 3, 7 pair, and 5, 5, so 5 has to go here. So I have placed all the 5s in the grid. Excellent. And now I cannot exclude 7 from this cage, guys, because I will need to put 1, 3, 7 in these 3 cells, because they can't be in the box, and there is no way to put 1, 3, 7 here. So which means that 7 is also inside the grid, inside the 37 cage. Superb, right? So we got 3 high values inside the cage. So we need 3 more digits which add up to 10, or we need to remove 3 more digits which add up to 11, right? So 7 is not in these cells, right? Because 7 is here, and even it's not here because of the 7 here. Can we look at this cage? So this is a 15 cage. Can you have a 9 inside? If you have a 9 inside, then the 6 comes from 1 plus 5 or 2 plus 4. Both are not possible. So 9 is not going inside the cage. Can you have an 8 inside? If you have 8, this becomes 3 plus 4 plus 8. Only possibility, because 2 plus 5 and even 1 plus 6 is possible, right? 8 plus 1 plus 6 is also possible. Okay, so this is a nice deduction, guys. So we are sure now that this cage cannot take a 5, and we need to exclude 11 from the total. So we need to exclude 6 more. The only possible way to exclude 6 more is 2 plus 4, because you can't have 1 plus 5 again. 5 is already excluded. So the digits which are excluded from this cage or 2 plus 4 plus 5. No other digit can be excluded because 5 is already excluded and you need to remove 2 4 to get to the 11. So which means that I need to put 2 4 outside this cage in this box. The only way to do that is if you have a 4 here and a 2 here. Superb, right? A very nice deduction. So which means this would be 2, that would be 6, and I can put it in the palindrome. So that is a 4, that is a 6. I have marked a 2 here, so that becomes a 2. And now I can place the 2 in column 8. So I think this cage must surely help now. Okay, this cage needs to contain 8 because if you don't have 8, we already saw that 9 is not inside the cage. If we don't have an 8, then there is no way to get to the 15 total. So 8 is going to be inside the cage. And to get to the 7, 2 plus 5 and 1 plus 6 are ruled out. So the only possible value now at this point in the solve has to be 3, 4, 8. There is no other possibility for the 15 total. So 4 is here, so that becomes 4. No 4 here, so that's a 3, 8. So that becomes a 9 now, which means 7, 9, 4. So this would have to be a 9, 7, 9, 4. So that becomes 8 now, and that becomes a 3. That becomes 8 now. And this 3, 8 pair can be resolved, so that's 8, that's 3. And the only possible digit remaining is 1, and that is the middle digit. So where do we get now? So let us look at column 6. 1, 3, 5, 8, 2, 4, 7. So this would be a 6 and 9, and that 6 gives you a 9 here and a 6 here. So the 3 possible digits left. Okay, you have 3, 7 here, right? So 3 is here already, so that becomes a 7, which means that this cell would be a 7. So that becomes 3. 2, 4, 7, 5, 6, 9. So 1, 3 and 8. 1 is staring at from column 4, so that's a 3. So that becomes 1, 8. And you have 1, 8 pair, 2, 5, 9, 3, 6. So this would be 4 and 7. But we know that 2, 4 and 5 are the digits excluded from this cage. So that has to be a 7. That has to be a 4. 2, 5, 9, 4, 6, 7. So the remaining digits in this row are 1, 3, 8. 3 goes here, 3 cannot be here. 3, 5, 7, 2, 6, 8. So 1, 4 and 9. 1 is not here, 4 is not here, and 9 is not here. 3, 4, 9, 2, 5, 7. So this would be 1, 6 and 8. And you have 1, 6 here. So that means that is becoming an 8. That becomes 1 and that becomes 6. Excuse me, guys. So because of this one, you get an 8 here and a 1 here, and that becomes 8 now. So that would have to be a 9. And this 8 resolves this 8, 1 pair. 2, 5, 8, 3, 4, 9, which means that these cells would be 1, 6 and 7. So you can't have a 7 here, so that's 1 and 6. So 2, 5, 8, 1, 6, 7. So that has to be 3, 4, 9. So you have 3, 9 here, so that becomes a 4. And that gives 1 here, a 9 here, a 4 here. That gives a 6 here. And these two cells would be 1 and 7. You have 1 here, so that's a 1, that's a 7. So 3, 9 pairs, that's a 9, that's a 3, that's a 3, that's a 7. And 1 and 8, so this would be 1 and 8. 1 goes here, 8 goes here, 6 goes here, 9 goes here, and that has to be 9 and 8. And with that, we have completed this gorgeous construction by Jonny Kaufman. I think we completed about 30% of the Sudoku in less than 2 minutes. I'm not sure. Once we got the crucial deduction in the Sudoku, the crucial deductions, if you see, we are noticing that this cell has to be equal to this cell and cannot go inside this cage. And then combining these totals in a meaningful way, combining these cages and this box in a meaningful way to get that they have a difference of 12. And the last part, noticing that this cell can only be a 5. That was the most crucial deduction in the Sudoku, without which it would have taken a lot of time. So hope you guys enjoyed watching me solve this Sudoku. Do let us know your thoughts in comments, and please subscribe to the channel and share the video around. We'll be happy if you do so. So we'll be soon to see you again with a video. Take care until then. Bye bye.